Hey you guys, it's me, Miss Arneson, and I'm going to talk to you right now about the different types of landforms that are caused with different types of plate boundaries. So if we're talking about convergent, divergent, and all of those plate boundaries. So let's go ahead and get started. I found this cool PowerPoint that I just couldn't pass up because look at how exciting it is with this bright yellow color and all these lines. I was like, woohoo, this sounds like the opposite of COVID. Okay, so here we go. Convergent boundaries. So you were supposed to have already been familiar with convergent and divergent boundaries, and then transform is the third type, and those ones move past each other, and there's kind of like, in my opinion, those are the most boring ones because they don't really do that much. But convergent boundaries are definitely going to be the ones that have the most going on. So when we talk about a convergent boundary, what's literally happening is you have two types of crust and they are both going the same direction. So what ends up happening is that whichever one is the heavier one is going to go under the lighter one. And that's going to be called subduction. So whichever one is the one that's going underneath, that's the subducting plate. And it's really important to know that convergent boundaries can also be called subduction zones. And this kind of plate boundary, you're going to get a lot of really interesting things going on. You're going to get big mountain ranges if it involves continental crust, and then you're also going to get volcanoes and earthquakes. So these are the ones where the most is going to be happening. Other plate boundaries are associated with other types of processes. Like you can still get volcanoes at a divergent boundary, but you're less likely to have earthquakes there. I'm going to show you maps of all this stuff. So I'm going to give you an example of each of these. For some reason, the state of New Mexico and really all states for science tests, they want you to be able to look at a picture and then say like if they put, like three different circles, they put a circle here, and a circle here. They want you to say where would a volcano most likely present. And so you'd have to know that this part where the oceanic crust is going under the continental crust, that's where it's more likely to have a volcano than over here. So that's why I'm showing you these models. If you want to sketch these or get a copy of this off the internet, you can just search convergent boundaries. You can keep that in your notes somewhere online so that you have that when you're taking a test, and that'll help you figure out the answer because the final exam is coming up soon. Okay, the same thing happens when you have oceanic crust going under other oceanic crust. There are a few examples of this that I'm going to show you guys so that you can see what all of these different parts look like. But you are still going to, where that lithosphere is going back under and it's getting hot enough to melt, you're going to have that rock turning back into magma, which is of course the liquid rock. And then when it comes out of the earth, that's when it would become lava. So they sometimes want you to know the difference between magma and lava. And the difference is, where is it? If it's underground and it hasn't reached the surface, it's magma. If it has, then it's lava. So here's an example of a convergent boundary, and this is one of my favorites. Oh, you know what? Let me go back to this really quick. Okay, so one of the big features that I forgot to mention about crust when it's subducting under another layer of crust is that you're going to get what's called a trench. If you've ever heard of the Mariana Trench, that's like the deepest part of the ocean, and it's just an example of a trench where you have one oceanic crust going under continental crust. Even though oceanic crust is very thin, you can see this like darker gray layer here compared to continental crust. It still is heavier, it's more dense, and so it'll still go under the continental. And where that happens, a little while offshore, you're going to get what's called a trench, and those are the deepest parts of the ocean. So when you talk about the abyssal zone, or you talk about organisms that are living off of chemosynthesis instead of photosynthesis, those are near trenches because that's where chemical energy, since it's so deep, is going to be coming up from the rocks, and they're going to be able to get some heat and have life down there even though there's no sunlight at all whatsoever. So I just wanted to mention that because they're important. So here is a big trench. This is the Nazca plate and the South American plate, and it's showing you, this is like a zoomed out view. You can see that there's a lot of areas where there's volcanic activity in this mountain range. That's typical when you have an oceanic plate going under a continental one. I'm going to move my face over here. Okay, And so this is what it looks like without a bunch of topography. This is just a political map with the lines. And you can see these arrows are going towards each other. So you would have this Nazca plate basically subducting beneath the South American plate. And when that happens, you get these big piles of land. That big pile of land becomes a mountain range. And of course, because that crust is going under and it's heating up, you're going to have volcanic activity, usually in the mountain range somewhere. There's also a really deep trench here. Now, because this plate is basically pushing up against the South American plate and the South American plate is pushing back, this whole entire south or side of South America is covered in mountain ranges. And it's kind of a cool mountain range where there's like, it's a total desert on this side. Usually coastal areas don't get so deserty, but it's a pretty cool landform. As far as I'm concerned, I really enjoy learning about it. Here's one where land, so continental crust is subducting under other continental crust. So which one would go under in that case? It would be the heavier one, the one that is more dense. And so the Himalayan mountains, which this map is kind of like maybe unfamiliar to you unless you're kind of a geography nut like me, but here is what's called the Eurasian plate. This would be Africa over here. This is like what you would consider the Middle East. And so here is India, and India is on a plate that is going north, and Eurasia is pushing back at it. And that means that you have this just gigantic mountain range. It's called the Himalayas. I'm sure you've heard of the Himalayas. The tallest mountain in the whole world, Mount Everest, is in this range. And it's because they're just pushing towards each other, and so these rocks just break and they fold and they just pile up until you get these huge mountain ranges called the Himalayas. So that's a pretty cool place as well. I think that's all I want to say about that. Okay, so another convergent boundary, in this one, I don't know, like I love Japan in theory. Like if you see pictures of it, it's so beautiful, but man, there is a lot going on there that has to do with its position in regards to plate tectonics. And so it makes me nervous to live there because they've got all kinds of earthquakes, all kinds of volcanoes, the population density is really high, and then there's always the risk of, because of the earthquakes that are happening, the tsunamis. So it's a pretty intense place to live, and but it is beautiful. So Japan has it's kind of an oceanic edge of the Eurasian plate, which is right here. So this is ocean on this side. The Japan is an island nation, and then on the other side there's also another plate that is oceanic, and they are subducting under one another. So this causes quite a lot of volcanic activity in Japan and earthquakes. So there's always, I mean, they have to be really careful with their engineering to keep the cities and things that they're building there safe. This is kind of a cool map. It also shows you the age of these rocks. So this is a quaternary rock, a neogene, and a paleogene, and I just thought that was kind of fun, so I thought I would point it out to you. So this basically part of the Eurasian plate is moving this way, and then since the Pacific plate is moving this way and the Philippine plate is moving this way, you get a lot of activity there. So convergent boundaries are going to be the ones where you get the most violent and scary type of natural disasters, like the earthquakes and the volcanoes and the tsunamis if it's in the ocean, because that's where all that activity occurs, is when these crusts are, you know, pushing into each other. They have to, one of them has to give, and when it gives, you're going to get some earthquakes. Okay, next. Okay, so divergent boundaries are still pretty interesting because you're going to get volcanic activity at these, not nearly as much of an earthquake activity. If you do, it's not because you have these big giant plates moving into each other. It's because you have areas that are basically like falling into the ground. So you can still have some earthquakes, but it's just not nearly as common. And you do get other kinds of volcanic activity like hot springs. So we kind of talked about how in our area, the basin and range, we have a divergent area of our plate. It's not a plate boundary. It would be called a fault, which is basically when part of a plate is moving within itself. So we have the big North American plate, and part of that plate is moving, and there's some fault. You might have heard of the San Andreas fault, which I think I have later on here. That means that there's just two parts of the rock on the same plate that are kind of doing something different from each other. These are when things are moving away from each other, and eventually, if you keep going for many, many, many millions of years, you get a new ocean wherever this divergent boundary is. So Las Cruces could eventually be an ocean again if time, I mean, if that much, well, time will pass that much, but will humans still be here to see it? I don't know about that. So here's where we have two continental crusts moving apart. If it's happening in the ocean, then we call it a rift valley in either, but the mid-ocean rifts are going to be like this, and so it's just spreading out. The elevation where the new land is being built is kind of pushed up a little bit. So if you take an aerial photograph of an area, you can actually kind of see it under the ocean, that there's like this pushed up area. I'll show you an example of that. And then if you have a rift valley, then, and so this is when it's still continental crust, you usually do get a river that's going down the middle. For example, in our we have the basin and range. So in our basins, we often have a lot of rivers in this landform that we live in. So what you're going to get here is the volcanic activity will be centered around where this new land is being formed. So let's look at some of those in real life. So here's what I was talking about with a mid-Atlantic ridge. So this is a composite image, which means that they've taken a lot of pictures and then they put them together. And this one is showing you elevation. So the lighter the color is, the less deep it is, the more shallow it is, and the darker it is, the more deep it is. And then red is the absolute highest. So you can see over here in this mountain range right here, which we were talking about earlier, these mountains get pretty tall, pretty big, because this subduction zone right here where the Nazca plate is going under the South American one. But we're talking about a mid-Atlantic ridge. So the mid-Atlantic ridge actually goes all the way up. This is Iceland right here, which we're going to talk about in a second. And then you can see it just goes all the way down, and you can trace it. So you can, I mean, this is evidence right there. If you can get somebody to take you to outer space and you can get some water penetrating radar or something, you could go see this yourself, but you probably don't have that much money. I don't. And here is Iceland. So the mid-Atlantic ridge is going through this island, which Iceland is a really big island. But it has a lot of volcanic activity here where these ridges are basically splitting apart their country. So like it's literally just pulling their country in two different directions. And you can see the ridge right here is filling in with water. So this is the Rift Valley right here. And it's filling in with water, and eventually it'll just be like filled in with ocean. But it's pretty cool. You can, I mean, you can go see like how the country is splitting apart. If you could live long enough to watch it, you would really notice this getting bigger and bigger and bigger. But because humans only live for like 100 years max, we can't really observe it that much because these things are only moving about centimeters each year. And so that doesn't end up being very much over even a human lifetime. Okay, transform boundaries. These are the most boring ones to me. I mean, they're kind of funny sometimes. Like you'll see a fence, maybe somewhere in California where like the fence has, or the road has been like split into two parts. And that's literally because they're moving side by side from each other. So you have one crest that's going this direction, one that's going another direction. And when that happens, you get earthquakes. Sometimes a little bit of volcanic activity pops up, but it's not nearly as common. Earthquakes are really what we get there. And as you know, like living in California, they know a lot about earthquakes. If you've lived in California, you may have experienced one yourself. And that's because this land is like crushing side to side next to each other. So it's these rocks that are rubbing together, and that causes a lot of friction, and then a lot of waves, a lot of seismic waves. So I wanted to show you a couple of cool maps, or maps that I think are cool. So you've seen some maps of the plates, and this doesn't have all the plates because there's like a lot of, you can break them down into like really fine little pieces. But if you've heard of like the Ring of Fire, that's an area where you just have all these volcanoes that are kind of going in this round shape right here, and that is because of the plate boundaries. So when people are talking about volcanoes, and you can see that those are going to happen along plate boundaries as well. There's a few weirdo things that I'm going to tell you about. I think this is Hawaii right here. And if you look, Hawaii, was formed by a volcano, but it's like right in the middle of a plate. How is that happening? Yellowstone is over here, and Yellowstone is basically in the middle of a continent, and it still has a lot of geothermal activity. So what's going on there? We'll talk about that in a second. And then here is a map of earthquakes. And again, you could line these up and see that along plate boundaries are where you're going to have the most earthquakes. So here in Las Cruces, we do not really get very many earthquakes. We do have some from time to time. There was one apparently very recently that some people felt, but I didn't feel it, and I was so bummed. If we could predict them and be like, hey, wait, there's going to be a volcano. I mean, there's going to be an earthquake or a volcano, like I might, be a volcano and earthquake chaser because that seems fun. So here's a couple of things that I'm just calling odd ducks. Like these are weird places. And the reason I'm calling them that is just because they're kind of like different. So Hawaii is what's called an archipelago. There's quite a few of them across the planet, and they are a hot spot in the ocean. So there's also hot spots on land, but when you have a hot spot in the ocean, what's happening is that there's this area, for reasons that we can't really like 100% explain, there's a volcanic area, and it's spewing up a whole bunch of magma, which of course becomes lava and then becomes rock. And so the crust is moving over the hot spot. And so this would be like the oldest of the Hawaiian islands over here, Kauai, and then the big island would be over here, and that's the newest one that is still having a lot of volcanic activity even today. Okay, when you have a hot spot on land, you get something cool like Yellowstone. And I put some pictures of Yellowstone in here because it's just amazing. So we have this magma that for some reason is closer to the surface. It heats up a bunch of water and causes like all of these cool things that I'll show you a picture of right now. So this is in Yellowstone. This is what's called the Grand Prismatic Pool. There's pictures of it where in certain light and certain times it'll turn red on the outside. I just picked this one because you can see the forest in the background. And then of course the people walking by. So this is like a boardwalk, kind of like you would have at the ocean. And if you step off of it, you can literally die. So you're not supposed to do that. You can like burn your leg off. So this is hot water that is in a pool coming up from the ground, and there's different organisms living in it, and the different colors are based on the different microorganisms that are living in the different parts of this pool, which is just like so cool. You can have geysers in Yellowstone, so this is where water consistently shoots out of the ground. There's one called Old Faithful, and it shoots out like exactly like clockwork. Like you can go see it at exactly the same time. It's like every hour, so I don't remember. I was there when I was a kid, but I didn't really pay attention to the time because I was a kid. Here's where there's kind of a waterfall, but there's minerals in the water because it's hot spring water, and so there's these beautiful like kind of like icicles, but of course it's like in what's it called? Yellowstone, where there's these mineral deposits like this. There's actually like huge swimming pools and stuff that you can go into in the area, and it's like a hot spring pool, and they stink. They smell like sulfur a little bit because that's part of one of the processes that happens with volcanic activity. So here's where there would be like a boardwalk and you could walk by and see all the different colors. And pictures don't do it justice. It's much prettier in real life. But I just wanted to share that with you guys because you have a test and you need to understand those boundaries. Let me know if you have any questions. Talk to you later.